Click the bell icon to get latest videos from Ekeeda.
Hello friends, as we have discussed about the Schrodinger's equation, so here basically we are going to talk about the quantum numbers. So what is the need of quantum numbers and what are the different type of quantum numbers? This is what I'm going to talk about. So now let's get started. So friends, in this topic, let me talk about the quantum numbers. So what is the need of quantum numbers actually? So quantum numbers gives us an idea about the electron, the position of the electron, the energy associated with it, as well as the electron around the nucleus. So these are the details that could be given through the quantum numbers. So let us understand what are the different types of quantum numbers actually. So there are basically four types of quantum numbers. The first one is principal quantum number. The second one is azimuthal quantum number. The third is the magnetic quantum number. And the fourth one is spin quantum number. So now let us understand the first quantum number, that is principal quantum number. The principal quantum number, which is denoted by small n, and in that case the n represents the main shell in which the electron is present. For example, if we consider the 11th electron of the sodium, so in that case the 11th electron is present in the third shell, that is the principal quantum number is 3. So this is nothing but the main shell it represents, that is known as principal quantum number. And now let me talk about the next one, that is azimuthal quantum number. Azimuthal quantum number is denoted by L, small l, and what does it means? Azimuthal quantum number, it denotes the presence of the subshell in the main shell. For example, as we understand, that is the first shell consists of only one subshell, that is S subshell. Talking about the second shell, it consists of two subshell, that is S as well as P. So that's the reason azimuthal quantum number is also known as subsidiary quantum number, and it gives the detail about the subshell. And it has a formula ranging from 0 to n minus 1, where n represents the principal quantum number. For example, if we consider the S subshell, so for that the azimuthal quantum number for S is found to be 0, for P it is found to be 1, for D subshell it is found to be 2, and for F subshell it is found to be 3. So this was related to the azimuthal quantum number, that is L. And now let me talk about the magnetic quantum number. Magnetic quantum number, it is denoted by small m, and it gives the detail about the orientation of the orbital around the nucleus. And this is what the most important factor that is I'm going to talk about, that is the magnetic quantum number. So magnetic quantum number gives us the detail about the orbital that has been present in the subshell. For example, if we consider the p subshell, but the p subshell also consists of 3 orbitals. So electron is present in which orbital, that is the detail that is been given by the magnetic quantum number. And how much orbital does p subshell have, how much orbital does d subshell have, how much orbital does f subshell have. So this is the detail that we could find from the magnetic quantum number. So talking about the example related to it, as we have got to know about the magnetic quantum number, that is it is denoted by m, but it has a formula, that is m is equals to 2l plus 1, where small l it represents the azimuthal quantum number, that is L. So for that, suppose if I consider the S subshell, so for S subshell, as I know, that is the value of L is 0, so therefore the magnetic quantum number it will be 0, that is it will be giving us only a one permissible value, that is 0, which is in fact we could get only one permissible value, and that's the reason that is the S subshell consists of only one orbital. For example, for P we could get 3 orbital, for D we could get 5, and for F we could get 7. So this was related to the magnetic quantum number. And now let me talk about the spin quantum number. So talking about the spin quantum number, it gives us the detail whether the electron is moving in anti-clockwise or clockwise direction. For example, the spin value of the particular electron, suppose it is found to be plus half, then it indicates that the electron is moving in clockwise direction. And suppose if it is found to be minus half, then it has been found that is the electron is moving in anti-clockwise direction. So therefore this all are the quantum numbers, and this gives us a very strong detail about the electron as well as the energy associated with it. So that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.